Okay, sorry, I thought it muted. Okay. Okay, so today I will be presenting this. Yeah,
I
yeah,
think you're working with Priya, right?
yeah. So
Just move to the section. What is GM matching?
it's 3D matching. It's an like I will explain. So like I will be presenting this comparative study on robust subset selection under noisy data. So focusing on mainly three state-of-art algorithm: GM matching, MISS, and PONSS. So like these methods aim to tackle a fundamental challenge in modern machine learning, like how to select small informative subset from a large data set that may contain noise, redundancy, or even adversarial samples. So like our problem statement.
He has dropped the course, right?
No, he hasn't dropped the course. He is just procrastinating till now and not giving any response. So we are assuming that he is. Yeah, we are assuming that he is dropping the course. Yeah.
So currently it is Lakshya and Utpal.
Yeah. We have added his name before. Yeah. Because he's in our group and he's done some work in the project.
Okay.
So, okay, so the problem statement, like in many machine learning tasks, especially with the large scale data, it's not easily practical or necessary to train on the entire data set. So instead, we want to select the subset of size K that retains the important structure and the information. So the challenge is that the real data sets are rarely clean. Like we have noisy labels, irrelevant or adversarial samples, domain shift or corrupted inputs. So to handle this, like we have some algorithms. So firstly, I will talk about the GM matching algorithm. Okay. So, so imagine we have a large data set and we want to select a small subset. We want to select a small subset that still captures the essence of the full data. So GM matching does this by minimizing a measure called MMD, which is maximum mean disparity, which quantifies how different two distributions are in high dimensional space. So intuitively, we want the subset to statistically indistinguishable from the full data set. So the core idea is that this MMD, we need to minimize it. So first, we do some type of embedding, which is like kernel embedding. So in the kernel embedding, we map the uh, we map the data point on a feature map that basically project it into the in a in a kernel Hilbert space. It is very rich. Uh, like basically we do this embedding to calculate the mean embedding, which is useful for calculating the MMD. So the overview of the algorithm. So the overview of the algorithm is like we start with an empty subset S. At the each step, we select a point that reduces the MMD the most and add it to the subset and repeat until we have K points. So this is called greedy herding.
So what are the properties of this MMD in the
So basically, this is the mean embedding, and this is the.
So you said geometry. There's a geometry.
So basically, while calculating the doing the kernel embedding, we calculate the geometry. We calculate this mu. This is from the like where we impute the geometric mean.
Yeah. So what are known properties of this function, which is the distance between the geometry mean?
Like I can't get your question exactly.
Mu is given the geometric mean.
No,
Yeah, it's a mean.
It's all about
So the geometric median. So geometric median. Mu is given the geometric median.
median, yes.
It's
Now, can you define what is geometric median? What does geometric median look like?
like actually it is mean, but it's used like it's not median, it's mean. I've read it in the paper. It
You have written geometric median.
yeah, it's basically we replace it with geometric median.
Yeah,
It
you
replaces
so that I will interpret mu g as geometric median.
like here it's mean. Like we will do it in the later part when we replace it to
You see, this is just the normal mean.
yeah, it's
Can you define that minimizes in that? So what exactly that is doing?
Because you are not, you say you are not defined MMD at all, right? What is MMD?
MMD is the like the difference of two means of the distribution, two different distribution. Like we want one distribution to be similar as similar to the other distribution. So that's why for the main distribution we are calculating the mean embedding, and for the subset we are taking and mapping them each point by point until we get the K subset. And that's how we are minimizing that whole MMD.
But as MMD is not defined here. Unfortunately, MMD is not defined here at all.
Um,
What is the basic difference between using the mean and replacing it with the median? What basically it does with respect to any problem? Why do we even replace a mean with a median?
like to make it more robust, like maybe two outliers, because like if the data set has outliers, the mean will change, but the median won't change. Because it was written in the paper that it was starting that's
Okay, I'm just two distributions itself, right? And we're looking at minimizing the distance of the means. That is
Yeah.
what MMD is about.
yeah, it's all about that. To minimize that and to make the subset equal to the full data set.
This is for two distributions.
Yes.
So how does it compare with K divergence? K divergence also measures distance across distributions.
I'm not completely aware of K divergence, but
There requires you to know the density, right? Here you're looking at means.
yeah,
What's the advantage?
like we were using means, but we found that median is more robust to that. So that's why we use
The MMD, you are not considered MMD. They're not interested in MMD.
um,
You started with MMD.
like it's the objective function that we are minimizing. That's the main.
MMD.
Yeah.
The objective is MMD, then I can understand where is median coming.
Basically, this is the median. I've mistakenly spoken that's mean, but it's we are minimizing the median of the two distribution.
Okay. So is MMD applied to median? Is that what you're saying? No. It's minimizing the distance of, if actually I forget MMD now. I forget MMD and say this is the distance between two the medians.
Yeah. But it's the square
It's properly. It's so confusing.
of the medians.
Okay, so this is very confusing.
Sorry for that. Like so like there are some steps like we have to follow first. Like first we do first we use the proxy encoder to first map the raw data to the vectors, like to use them in the kernel embedding to like further embed them in the where we are using this in the MMD, and after that like we can get the data set we want. Like it basically it's very useful in images data set. because they have noises a lot. So these type of algorithm works very good with image data. And like for the second algorithm, Utpal will be presenting the.
So in this part, MISS, it's a
So
most
you're done with your paper?
No, it's the whole presentation.
No.
Like in the last, we will compare about.
You have finished one paper.
No, we are finished with explaining what GM is. Now we will explain what MISS is, and the third part is what P1SS. Then we will compare how these are relevant to the
But
separate signal.
papers or same paper?
It's different papers.
Yeah, so in this MISS most influence subset selection, in this we try to first we remove most influence data subset from the training set and then retrain and try to maximize the prediction difference between these two models, and that's how I find the most influenced subset selection. And it's a parameter shift if simple we remove a most influenced subset, and it's not performing well. Sometimes it's incorrectly perform in a linear linear model.
It's not performing well at distribution.
Uh,
Most influential subset is the greatest effective model output. So, but what is this pi? What is this theta minus s?
this is the prediction function.
Yeah, but what is minus s?
It's when we remove subset most case subset from the training set, and then we find difference between
So is the theta estimated on a subset without s?
yeah,
This is theta.
we remove from some.
So the influence of s on theta.
Yeah.
Next.
And then there are two methods, greedy and adaptive heuristic identify influence group. And the greedy, we have first provide weight, but after that we can't update any weight, and on based on that we select most influence point, and this may affect where, but in adaptive we do it every iteration. We reevaluate the uh, weightage, and then in that we can find the most influence subset, but in greedy we aren't. So in greedy we assign the statistic score to each training sample.
So I need to go to the link.
And select the top K sample with the highest score, and return those most influence subsets. But in adaptive, we start with the full data set and recompute score based on the current model and remove the most influence sample, and repeat this step until we find the K samples are K samples. And in so adaptive heuristic is the handle non-additive influencer and better at modeling contextual importance. And in XAM influence, heuristical, we calculate the each sample score and try to estimate, and After that,
What is H here? What is
H is Hessian loss function.
Is it loss function?
No,
Is it not loss function? What is
Hessian of the loss function.
it? Is it not the loss function? Which
Yeah.
one? It's loss function.
Loss function is this one. L F.
Some of the gradients, L is a loss function.
Oh,
So how y is is an approximation of the inverse function is an approximation
mesh.
of MIS. Look, the previous slide. The MIS is, you're saying that the solution to MIS, the solution to MIS is or the maximizer of MIS?
Most influence. Yeah, maximize this function.
So F that minimizes MIS is 1. What is the connection between this and the influence function? Go to the influence function.
Influence function. Yeah.
What is influence function approximating? What is it approximating?
Influence function.
This is approximately the max value of theta minus phi of theta minus phi of theta. What is the influence function approximating? You're saying approximate using influence function. What is it approximating?
It's maximizing the divergence.
Maximizing
Distance.
distance between what?
Distance. I mean, this function. This prediction of 2 phi theta s
Yes.
theta
Is
minus.
that the max value of this difference or is it the, no, I'm not understanding.
Max value of that distance.
There is no S anywhere. But where is S to I? For all I in S.
As is the subset we remove from the original training data set.
The function on the right is approximating, not the, so phi of theta minus S minus phi of theta. That is approximated by this, is that what you're saying?
What?
It's a quadratic approximation, finally it's a quadratic approximation, right?
Yeah.
So are you saying that phi of theta minus S minus phi of theta is approximated using IS, is that correct? Is that what you're saying?
Yeah, we influence.
But what is the role of loss function then? Go back to the previous slide. There's no L here, where is L? Currently, how is L coming in the
No,
equation?
it's a phi of s is function of loss.
So how is phi a function of loss? Can you show the different correction between phi and loss? Can you show the correction? Is there somewhere?
Yeah, I think in this paper I don't include, but in SS paper, phi of s is a full. Yeah, so this is research purpose I'm going through, and yeah, this is and this is what I'm exercise.
The quadratic function is approximating what? The phi of theta minus phi of theta, is it right?
Yeah.
Where is the approximation talked about in this paper? Please go down.
So influence ways.
First order.
Okay. Where is this mentioned as an approximation and what is an approximation to? Where is it mentioned as an approximation?
Yeah, this.
Additive structures provide the group effect can be approximated by summation conclusion inferences. Additive structure group effect can be is approximately what?
I think we to evaluate the
Basically, that's the term. Using children and what that data is. I think this is the approximation for this difference.
Yeah.
A minus.
Yeah.
A minus.
Basically, this is been approximated in the first
A
order.
minus.
Yeah.
Put A minus.
It's the subtract.
Go back to A minus. Where is A minus is defined? Yeah, we put an actual amount of units.
Yeah, man.
So this is what so I think this is what I have to answer. Why is it taking so long? I kept on asking, is the difference in that argument maximized? You're not even respond. Okay, next.
List paper.
Okay, go next. Next. So what is theoretical bound?
what?
What is the theoretical bound?
Theoretical one. Yeah, this part is presenting third person. But
Sorry.
this part is presenting third person, but it's not present.
So the third person prepared for it.
Yeah.
You didn't prepare.
No.
But this is part of a different paper?
Yeah, this is the completely different paper, PUNSS. So basically, these three papers were comparing about how they are dealing with calculating the subsets.
You've not gone into the depth of anything. Other teams in the present they go through the details there. I have checked it out and I see I mentioned this medical guidance some answers. Okay, next. Your noisy evaluation. So this is approximation guarantee. Complicated books. The teacher will be absolutely. Okay. So later on the
Actually, this paper, they have performed by
why? By what is
tables.
Hey, so you don't spend time on this, is it? It's a significant weightage, right? Weightage. Suppose,
Yes, sir, we have.
and you are the last to present. If you have more time than everyone else, there are teams who presented 1.5 months back. Someone who presented very good 1.5 months back. So you can't say that you have so much time. So what is okay, next? I mean, next. We have a comparison.
Okay,
So
so
once by forget, you don't understand what's happening there.
okay, so GM matching is fundamentally a distribution matching algorithm. Like it uses kernel embedding. So basically, its robustness is high, and like it's elegant and distributional than MISS and PUNSS. as compared to MISS, which is statistically grounded and lightweight. Like in MISS, it take a different route. It performs spectral decomposition of the data using a filtered mean, and it essentially remove the components likely to be corrupted by the noise. But in GM, like it's different. So that's the main difference between these two. I'm not sure about the PNSS. And like the best use case for GM is the image data, and for the best use case for the MISS is
have various dictionaries. So we were thinking how to have one, so we were thinking to have a median out of the embedding cloud, which is obtained from the dictionary of the.
Okay.
So that, from there, I got that GS magic paper and that POMS.
Where was it published?
It's really very simple idea. We were also people.
So saying there's no guarantee for MISS. But you just said that it is an approximation, right?
MISS. Yeah,
Based on approximation.
Yeah, it's basically
First order,
improved.
second order approximation.
It's first order MISS.
Yeah, it was HCL.
And
Second order. Best use case is regarding the most basic, okay? So you're saying GM matching, they are definitely, they are clear.
yeah,
Your understanding of their best use case.
like the best use case for GM matching is for image data that has
So
noises.
assessment or their.
Their assessment. They are like not useful for.
It's a claimed use case. It's not, it's a claim, therefore they claim their use cases. On the Pareto front is exactly what I talked about earlier, right? Because not a Pareto front here. Okay, so I have to mention for bonds. Interesting. Okay, what's the project?
Like in a project.
It's okay, you can speak. What is the project on?
It's on a bookset repository utilization.
What did I told you from the last meeting? Can you just repeat this? What did I told you that what we will do? Just a back दो बार. Simple भाषा में use जैसे आप.
Basically हमने web scraping और इन सबसे data collect करके we try to clean them and try to make subsets that are useful and get information to that. Like contains that information that the whole data set contains, and it's useful for like the model to be trained easily and fast. So basically.
सर तो हमने वो हमारे PhD group में I have sent the drive link. So I put it actually the write-ups. So they are basically doing that LF's subset selection for the data for the. So they are doing one of the baselines, and one team from aerospace department they are doing another base from our pipeline.
Okay,
so they will be coding for. I have written. I can share on that drive link. I have shared the write-ups which. VC++. So various baselines were from Sphere, from retreat that we are doing. One is VC that Palani Jain team has presented that day. So they do have applying.
Okay.
One of the baselines there.
Okay. Fine. But yeah, I mean, more is it. So first of all, did you attend some of the other presentations? There was a conscious effort to present one paper in depth. So you should attend some presentation, see how thorough they are, right? So this was not acceptable, right? I mean, it is,
Actually, I don't know why you guys are very late in.
you're first of all the last to present, and then you're totally shallow, right? I mean, you would have gone into the depth of one. People at least prepared experimental results. There was no slide, nothing in it. Seems to be very last minute effort. So I assume for your post project, you'll take it super seriously. You have to work with the TAs. You can't just be not meeting them. How many times have you met?
So they have just met me in that last minute record, 30 just missed the record. That's it.
We were able to contact her from the start.
You're not?
We were not able to know that she was a
But it's already there in the spreadsheet.
The others got.
Everyone has got. Come on, I mean, you can't be one or two exceptions. Everyone got. Yeah, you didn't spend any time. I think that's the best.
I am giving the complete write-ups of what to do, what to not do. To other.
Yeah. After we are contacted, we are.
Again,
we'll know.
Yeah, but you have to reach out. I mean, it's there in the spreadsheet. Okay, so I expect a lot